All right, guys, I just want to give you a quick rundown on what you're doing with this table. Hopefully by now you've analyzed the graph and you've come up with these numbers for the period of each of the orbits of each moon around Jupiter and the amplitude, which you can obtain, as I talked about yesterday, by looking at from peak to peak and also from the black line up to that's the amplitude going up. So hopefully you've come up with those numbers already and figured out how long it takes for these moons to go around Jupiter. After that, you're essentially following the directions that are listed here under part 3, just step by step by step. You're just doing a little bit of math to figure out the mass of Jupiter. Our end goal is to have a mass of Jupiter which is identical for all 4 planets, or for all 4 moons, I should say. That's probably not going to be perfect because you got some errors involved, but no big deal if you do. So I'll do Io with you. The period that it takes Io to go around Jupiter is about 2 days. We're going to convert that into years just by dividing 2 by 365. So again, you're going to need a calculator to do all this. So 2 divided by 365 equals that very, very small number. And I'm going to type that in right here, 0.0055. Okay. And you can round it off at some point because obviously that's a lot of digits. Then we're going to take that same number and we're going to square it. So I squared that number. Square root of that number is 3 times 10 to the negative 5th power. Okay, so that's it's a much smaller number. All right, so now we're going to deal with our amplitude. The amplitude is going to be the major axis of our ellipse, and it says to convert this to something that's related to astronomical units, and we can do that by dividing by dividing by 1050. So let me clear this out. We have 2.7 times 1050, and that's going to give us this number, 2,835. Okay. Oh, I did that wrong. It's not multiply, it's divide. My bad, guys. I'm sorry. So 2.7 divided by, I knew that sounded strange, 1050. And that's going to give us a very small number. That's more like it. Okay. So we have a very small number, 0.00257. Okay. So again, a pretty tiny number. Now we're going to take that number and we're going to cube it. So we're going to multiply by itself. So 0.00257 times 0.00257 times 0.00257. Okay, so that's the cube of that number. Again, a very, very tiny number. And I'm going to put that all in here. 0.000000. That's 6 zeros. Okay. Actually, it's 7 zeros. And that's, I'm going to say 17. All right, so a tiny little number there. Now, in order to get the mass, this is actually Kepler's third law combined with Newton's law of gravitation. He said that the mass of the object that it's orbiting is equal to the period and the amplitude combined together, the semi-major axis cubed over the period of time it takes to go around squared. So we're just going to have to do a little bit of math to figure that out. And I'm going to take these two numbers and divide them that I've already gotten here. Okay, so let's divide these numbers. We have on top that number divided by this number right here, which is a very tiny number, 0.00000, right, to the 5th power, negative 5. 1, 2, 3, 4, 5. And that's 3, okay? And that's going to give us our answer, which is a pretty tiny number, okay? 0.0057. And now we're going to have to multiply by this number right here, 2 times 10 to the 30th power to get it into kilograms, okay? So that's going to be our mass of Jupiter. So you're going to have to do this probably on your own calculator. I can't do it on screen. So you just multiply this number that you just got by this number right here, 2 times 10 to the 30th power. So if I do that on my calculator, and you can't see this because I'm doing it on a calculator in front of me. So 2 times 10 to the 30th power times the number we just got, 0.0057, is going to be equal to 1.14 times 10 to the 28th power. So it's a very large number, okay? And that's what I got for my answer. Now, that's hopefully your goal, to get that same or very close to the same number for all 4 of these. I'm guaranteeing it's not going to be the same, and I'm guaranteeing that you're going to have some error involved, mostly because we're guessing on the amplitude, we're guessing on the period, and you're also like going by the numbers that I came up with originally based upon picking those where those locations were on the map. And that was very difficult. So you might not get what it should be, and what it should be is right here. And so what you're going to do down here is calculate your percent error from your average. And I'm guessing it's going to have a little bit of error. All right, no big deal. And then I just want to know your thoughts. What did you think about this? What did you learn? What conclusions can you make from this lab? What's interesting to you? And you can answer that question there. Okay? If you have any questions about anything, just send me an email. Hopefully you can get this done on your own, and then we can talk about it more next time you're here. Okay?